So today we're going to be talking about the rest of lesson 4.2, radians and degrees. First thing we're going to talk about is arc length. Arc length is the length along a circle made up by my degree theta and the radius. So you'll see right here, S denotes arc length, and it's made up of the radius times my angle, where angle theta is measured in radians. So if they give you an angle in degrees, you need to change it to radians. So remember, anytime they give it to you in degrees, you could also use this equation right here if you didn't want to change it every time. So you can put both of those down. It'll give you the same answer every time. It'll just convert your degrees into radians in the equation itself. So let's look at this one right here. It says find the length of the intercepted arc in each circle with the given central angle, measure, and radius. Round to the nearest tenth. Okay, so the first one right here is my angle, pi over 4, and my radius is 5. So we again look at the equation. S is equal to theta times the radius. Theta is my angle in radians, which is pi over 4, times my radius, which is 5. So my arc length is going to be 5 over 4, or 5 pi over 4 centimeters. Next one, letter B, 60 degrees, radius is 4. So we need to change from 60 degrees to radians. So remember, we take degrees times, we did 180 degrees over pi, or pi over 180. Those can cancel each other out. This is 1 and this is 3. So I would get pi over 3 radians. Now that I know what it is in radians, I can find my arc length. Remember, it's theta times the radius. So in our case, that would be pi over 3 times 2. 2 pi over 3, and it was in inches. You can try these problems on your own. Feel free to stop the lesson video and try them in your notes. Now, the next thing we're going to talk about, linear speed and angular speed. So, formula for arc length can be used to analyze circular motion, motion that goes in a circle, obviously. The rate at which an object moves along a circular path is called the linear speed. The rate at which the object rotates around a fixed point is called the angular speed. So you can see the distance, or the difference. Difference is linear speed is around the circle, angular speed is around the fixed point. So, right here, suppose an object moves at a constant speed along a circular path of radius r. If s is the arc length traveled by the object during time t, then the object's linear speed is given by this formula right here. Notice you'll see that linear speed is denoted as the letter v. v equals s, the arc length, over t, which is time. If theta is the angle of rotation in radians, remember it has to be in radians, through which an object moves during time t, then the angular speed is that W looking letter, okay, that's gamma, of the object, then it's given by gamma equals the radians divided by time. So that would be when you're looking for the angle of rotation, or excuse me, the angular speed. So let's look at this example right here, example 5. Find the angular and linear speeds. So during one delivery, the tires rotate at a rate of 140 revolutions per minute. Find the angular speed of the tire in radians per minute. So, if we know that we have 140 revolutions per minute, we need to figure out what that is in radians. 140 revolutions times, remember radians, all the way around a circle, one revolution is 2 pi. So this ends up being 280 pi total revolutions. Okay, that's what it is in radians. Then we look at our equation. Okay, 140 revolutions in 1 minute. In radians, that's 280 pi over 1 minute. So if you were going to simplify that any further, this could be your answer, but if you wanted to get a number for it, you take 280 times pi divided by 1. That reduces to approximately 879.6 radians. On part of the trip to the next delivery, the tire turns at a constant rate of 250 revolutions per second. Find the linear speed of the tire in miles per hour. So first let's look at the 2.5 revolutions times 2 pi, which is a full revolution. That's going to be a total of 5 pi. So it goes over 5 pi revolutions per second. Now, if we're trying to find the linear speed, remember that's v, and v was the arc length divided by time. So, arc length again, let's just substitute in our formula for it. Arc length was radius times theta over time. So our radius, when we look back in our example, if the diameter all the way across the tire is 30 inches, radius is going to be half of that. That's 15 inches. Okay? Times, we set it at a constant rate of 5 pi revolutions per second. So that would be 5 pi. And my time is 1 second. So I multiply that together, and I get 75 pi inches per 1 second. Now, the difference is they want our answer in miles per hour. So we need to convert from inches per second into miles per hour. So first, I'm going to say 75 pi over 1 second. Top is inches. So let's change my seconds into hours. So in 1 second, in 60 seconds, there is 1 minute. Okay, and in 60 minutes, there is 1 hour. Okay, I'll stop there for a second just so you see what's happening. The seconds cancel out here, minutes cancel out here. I'm left with hours on the bottom. Now we need to change inches into miles. So in 1 foot, there is 12 inches. In 1 mile, there is 5,280 feet. Again, I'll stop for a second so we can see what's happening. Inches are canceling out here, and feet are canceling out here. So we're left with miles on top, hours on bottom. When I multiply this all through, I end up getting approximately 13.4 miles per 1 hour. You could try this problem right here if you'd like in your notes. Feel free to stop the video at any time and try this problem right here. Last thing we're going to talk about is sector of a circle. Now, sector is a special region that's bounded by the central angle and its intercepted arc. So that would be this whole thing right in here that's colored in blue, right here. This is going to be the sector of our circle. Okay? So, equation for sector is this. Okay? The area A of that sector is equal to 1/2 times the radius squared times theta, where theta is measured in radians. So again, pretty similar to what you've talked about earlier when we talked about circles, but again, it's going to be 1/2 radius squared times theta. And we could figure it out. They showed you the work above if you're interested in how they got that. So let's look at this one right here. Find the area of the sector of this circle. So the equation that we're looking at, again, is 1/2 radius squared times theta. Nice thing is they've given us everything that we need to know here. Okay? 1/2 is still going to stay 1/2 times my radius is 3 centimeters squared, and they gave us our angle in radians, which is nice, 7 pi over 8. Okay, so when I do that, 1/2, 3 squared is 9, 7 pi over 8. What I end up getting is 63 pi over 16. And that's going to be my answer. If I wanted to simplify any further, it's approximately 12.4 centimeters if you wanted to simplify it any further. All right, next problem we have right here talks about windshield wipers. Find the approximate area swept by the windshield wiper blade shown. The total length of the windshield wiper mechanism is 26 inches long. So the first thing we have to do is we have 130 degrees, and we need to get this into radians. So I take 130 degrees times pi on top, 180 degrees on bottom. Okay, how can I simplify this further? Well, a 10 goes into both of them, so this is going to be 13 on top, this will be 18 on bottom, and so I get 13 pi over 18 is what my measure is in radians. Now, if we want to figure out the length of my area, we have to figure out what this is right here, okay? Because we don't want that, we just want the windshield wiper itself, this part right here. So what we're going to have to do is we're going to have to find the area of the whole sector and then subtract out the sector that we don't want. So what we're going to do is we find the area of the whole sector itself. Area of the whole thing. 1/2 times radius squared times theta. Okay? Whole area itself, okay, the radius they said is 26 inches squared, and then the angle stays the same, 13 pi over 18. Okay? So I put that into my calculator, and I find that that's going to be 2,197 pi over 9. If you're wondering how I got that, go ahead and do it on your own on your calculator. Now, we have to find the area of the second part, the part that we're going to subtract. So that's going to be 1/2. The radius is going to be 10 inches squared, and 13 pi over 18 stays the same. Multiply that out, and I get 325 pi over 9. So when I subtract these two, because that's what I'm going to want to do to figure out my total answer, 2,197 pi over 9 minus 325 pi over 9 ends up being 208 pi, which is my answer.